Good morning from Utah. My name is Matt Cederberg. I'm the CEO of T-Splines Inc. And I am pleased to invite you to today's webinar on how to use T-Splines and ZBrush for reverse engineering and organic modeling. I'm joined on today's webinar with Kevin Pascoe, a designer who has used the T-Splines ZBrush pipeline to create over 25 models for production over the past year, and has used that to significantly increase his productivity by using the methods that he will be showing you today. Before we jump into Kevin's presentation, let me take a minute to introduce you to T-Splines. So most of you are probably familiar with T-Splines, but as an introduction, it's the name of both our company, T-Splines Inc., and our technology, T-Splines, which powers add-ins to Rhino and SolidWorks that provide a new way to create and edit smooth models in CAD. Today, T-Splines is used by designers, architects, jewelry designers, and toy designers to make aesthetically pleasing shapes that can be manufactured or passed downstream to other CAD applications. Many designers treat T-Splines like digital clay, and they will push and pull on the surface to get beautiful aesthetics. The T-Splines technology is something of a Rosetta Stone. In 3D modeling today, there are three main types of technologies used. Two of these are NURBS and subdivision surfaces. NURBS are well-defined, smooth, four-sided surfaces which can be combined to make more complex surfaces. They can easily be booleaned and trimmed, so they are the standard used in CAD and engineering programs like SolidWorks, Rhino, Alias, Pro-E, and others. However, since they are four-sided, it's hard to do organic modeling with them. Subdivision surfaces, on the other hand, can represent any shape, which makes organic modeling easy. However, since you can't exactly trim or boolean them, they are generally not used in CAD packages. However, this isn't an issue for visualization, so subdivision surfaces are a main technology used to create amazing images and models in programs like Maya, 3D Max, ZBrush, Moto, Cinema 4D, and others. So if you look at the combined technical benefits of NURBS and subdivision surfaces, they can really cover any modeling needs that you might have, and it's a pity that historically these two worlds have been so far apart. And specifically, there's a lot of benefits that artists enjoy that can be really big productivity improvements for designers and engineers. So T-Splines was invented specifically to fill this void. Let's go back to that. T-Splines are a smooth, precise surface, and they can represent arbitrary shapes. T-Splines can be booleaned and trimmed, so manufacturing and engineering is easy, and making complex organic shapes is also easy. And inside T-Splines 3 for Rhino, we have many tools for advanced surface creation to make models both organic and precise like this airplane. So one of the advantages of T-Splines is that it's compatible with both NURBS and subdivision surfaces. This means that as a T-Splines user, you can leverage other software that can import or export OBJ files, which is a standard format for moving subdivision surfaces around. And today we'll be focused on one of these packages called ZBrush. So what is ZBrush? It's a digital sculpting tool that can be used to create high-detailed models. It's often used for art or visual effects. These are some examples of the amazing detailed models that can be created using ZBrush. Here's just a close-up on one model. You can see that you can easily create much finer details than you could even manufacture. ZBrush has many powerful tools, but today we will focus on just two ways of using ZBrush that bring value to designers using T-Splines. First, ZBrush can be used to process and retopologize scanned data in a way that it can be used by T-Splines. And second, ZBrush can be used to add fine sculptural details to your T-Spline model. And just one note, we are not affiliated at all with Pixelogic, which makes ZBrush. We're just offering this webinar to show something that we think might be of value to T-Splines users. And you can learn more about ZBrush at pixelogic.com. So just in summary, today we'll be showing how T-Splines and ZBrush can be used as a viable workflow for you to create high-detailed CAD-suitable models and also to use scanned organic models in CAD. And this is also an affordable combination. You can get ZBrush and T-Splines for, let's see, for under $1,500. So with that, let me turn the time over to Kevin Pascoe, one of the designers who first turned us on to the power of this combination. Kevin will be doing live demos of both ZBrush and T-Splines as he shows you how this all works. Some background on Kevin. Kevin Pascoe received a BFA in toy design from FIT in 1996. Since then, if there's a toy company you could think of, he has worked for them, either internally or as a vendor. Kevin uses a variety of software tools in his daily work at his private design consultancy, including Rhino, SolidWorks, ZBrush, and T-Splines. As we mentioned earlier, in the last year, he's produced over 25 models for manufacturing using T-Splines and ZBrush. You can learn more about Kevin at his website, cropcircleportal.com, and he's available for freelance work. Kevin works closely with Kyle Houchins, a T-Splines trainer who is a regular on these webinars with us, and Kyle will be on the line today as well, so if you hear another voice popping in during Kevin's demo, that will be Kyle. And one final note, please type us any questions you have during the webinar. We have some additional T-Splines staff here to answer your questions, and we'll type them back and then also give Kevin some time to answer questions at the end of the webinar. So with that, let me turn the time over to Kevin Pascoe.
Okay, am I in?
You're in, and just go ahead and show your screen.
Okay, let me know.
Okay, you're on.
Okay, so I'm going to show a really powerful workflow that allows you to bring the scan data at whatever level that scan comes in at and be able to retopologize it in ZBrush. And a side benefit to this retopology tool inside of ZBrush is it converts any scan that comes in as triangles into quads, and T-Splines loves quads. So let me begin where I import a scan as an OBJ file. I just click and drag in the middle of the screen. If you hold Shift, it'll snap it to 90-degree constraints. And I go into Edit because that's basically what we're going to be doing. We're going to be editing inside of ZBrush. Now here's my scan. This is a good scan. This is pretty tight. It doesn't have any holes in it. It's a manifold poly file. This retopology workflow and the tools inside of ZBrush are pretty amazing. It's amazing what you can sample from a really low quality scan. There's some tutorials. One tutorial that's great that shows how you can work with a really low quality scan is done by Ryan Kingsland, and he has some workshops and some tutorial services that I've used that are phenomenal. But this scan is really good. Now, reasons why you start with scan data might be you want to just sample the volume and proportion and sculpt from just the volume and proportion to create something your own based on something existing. Another reason you'll use scan data is to straight reverse engineer it, where I bring this file in one form and I want to manipulate it with tools from another software and basically take a scan into a software where I can engineer it, manipulate it. And I'm going to cover both of those possibilities in this demo. So let me turn on the polyframe, draw polyframe, and here we can see our triangles. This is all polygons. It's not necessarily all that clean. It's got some clustering, it's got some artifacts, and it looks like some of these clusters are a result from the scanning software filling holes. Now these retopology tools were created by ZBrush to clear this up so the ZBrush tools work better. And again, the side benefit is It also benefits us in T-Splines. Any procedural tools that you run across an area where the topology is inconsistent, your tools are going to give you inconsistent results. And I'll give you a little example. I'll turn this off for a second. I'll draw around in here with a standard tool brush, standard brush, and when I smooth it, you can see the inconsistent result where it runs into those higher density areas of polygons, and that we don't want. So let me undo out of that. And now we're going to get into the actual retopologizing. So the first step, we're going to start in the subtool toolbar, and we can see our sample mesh. This is our scan. And we're going to go down into the Remesh button in the subtool toolbar, and right away there's some axis constraints that we want to turn off. This is an asymmetrical model. We're not going to be doing any symmetry, using any of the symmetry tools. And for purposes of this tutorial, I'm going to bring this sample way down, and that'll become clear a little further down. Now I hit Remesh, and what it does is it gives me a, let's turn on the ghosting, it gives me a pretty loose sample of my scan. Now this is a manifold mesh, all welded up, airtight, watertight, of quads. And I'm going to go into, I'm going to select that new subtool that the Remesh All gave me, and I'm going to subdivide it a couple times. Go into the geometry toolbar, divide, divide, divide. Now we can go up and see the poly counts. This went up to 550,000 polygons. Now, there's a sub-D function inside of ZBrush along these divisions where there's history and there's a lot of benefits to modeling inside of ZBrush, but it's also going to help us with our retopology of our scan. Now that I've got this dialed up pretty high, I'm going to go back into the subtoolbar and make sure that my sample is visible. I'm going to turn off the ghosting, and I'm going to hit Reproject All with the default settings. There's nothing that I need to be concerned with the default settings here. Reproject All, and sorry about that technical difficulty. Let me turn this off. All right, sorry about that. I don't know how much of that transmitted. Yeah, let's go back to ZBrush. So I'm going to come back into my subtool toolbar. I'm going to hide my original sample, and this is the result of the shrink-wrapped quads that shrink-wrapped around my original scan. Now, this is not very fine. It looks a little tessellated because of the limited amount of polygons that I'm using. But in the purpose of taking this sample, this conversion from the scan into T-Splines, you don't want to have millions of polygons, because you're going to really tax your hardware inside of T-Splines. So there's some, if you want to make sculptural changes, you can make them here. If you're doing a straight reverse engineer, you can dial this all the way up to 1,000,000 polygons and reproject this onto your mesh, and you'll get a nice, tight representation of the original scan. And with a burly machine, I've got a pretty burly machine, 8 cores of i7 processors. It will convert that million polygons into a T-Splines object. When I say it, I mean T-Splines will convert that into a T-Splines object. But for right now, we're going to do a low sample, and I'm going to show you how you can manipulate that inside of T-Splines. But before we bounce back out into Rhino, I'm going to show you some retopology strategies before you export into T-Splines. Now, I've got some topology here where I've got a crease in the mouth, and the topology isn't following the sculpt. So I can fix that by using a move tool, dialing down my draw size so I only affect one quad or one vertex at a time. And I'm going to drag these into the proximity of where I want them to be for my sculpting down the line. Now, one of the benefits of the history you'll see is I can go back up into my subtool toolbar, reproject to higher sub D, and it will move my topology without affecting my sculpt. So say I want to move this a little bit further, I come down the chain, move these a little bit more, and you want to try to keep an even distribution of quads, so you adjust around your changes. Come back up, reproject, and I'm getting closer to where I want this mouth crease to be. So now that we've got this, now that you've gone through your whole model and you've adjusted the eye topology, you've adjusted the hairline, you can come back out. Oh, before we do that, I want to show you how to export these. Now I've got 4 levels of polygon tessellation. Now if I go up and I export, I can export as an OBJ this file. Now that's not going to take all of my levels of definition. I need to export each one of these individually, and what that's going to give me is each one of those files that I import into Rhino is going to be a separate level of detail that I had in ZBrush. And I'm only doing that right now for demonstration purposes to show you the results. Now this is the first level of detail, the lowest level of detail. This might not be enough for you to start sculpting. Here's another layer up. It's up to you to decide what level of fidelity from the scan you want to start with. I'm going to turn these off, and I'm going to start here. This is a good representation, and it isn't too many polygons that with my hardware it's going to tax T-Splines. This is a real comfortable level for me. So I'm going to take this, it's a mesh. We can see that's a mesh. And I'm going to convert this. There we have our first level of detail. Now, Matt and Kyle, are you still in?
Yep.
Okay. Okay, just checking. Okay, so here we have a T-Splines mesh. It's converted really quickly. It's not too heavy. And I can go in and gain the benefit of all of my T-Splines and Rhino tools. I can come in here and start sculpting.
Just one question for you, Kev, as you sculpt a little bit. You'd mentioned earlier on when you were in ZBrush some kind of rules of thumb that you use as far as number of faces that you feel comfortable bringing into T-Splines. Could you just kind of repeat, like, what do you like? What's an average number of faces that feels comfortable for you for actually working in T-Splines, and then what's kind of the max amount of faces you've been able to bring into T-Splines just to convert to NURBS?
You know, it's really dependent on every application. When I say comfortable, what I mean is there's no lag here when I move verts. There's no lag when I select edges, and it's going to be dependent on what you're going to do. Right here, I'm approaching this as if I'm going to resculpt this, and I don't want to necessarily copy my scan, but I want to get a proportion and volume sample from my scan to start sculpting in T-Splines. So I'm not, like, again, I'm not trying to copy the scan, I'm just trying to use it as a sample. Now, if I open up this level, it's going to take a second because it's pretty heavy. I'm going to open up a reverse engineering example. So these are very heavy meshes. I hope you can see here, this is our triangles, our polygons from our scan. So that's our original scan. Here we've got our ZBrush conversion. This is all quads, but there's a lot of them. If I convert here, it's going to take about 15 minutes. Let's see, poly count. Poly count. This is 1.6 million polygons. Now this converted in T-Splines. T-Splines converted this, but given the hardware that I have, I'm going to have lags sculpting with it. Now this last in the row is an example of T-Splines converting this into, let's do that again. Hide this, having network issues. All right, so here's our patch layout of the result of T-Splines converting this quad mesh into NURBS. This is our NURB patch layout. And for demonstration purposes, I took that mesh and I ran a Rhino Boolean tool on it. So it's fully manipulatable, malleable in Rhino as well as T-Splines. So we've got original scan, two approaches on how to deal with this in ZBrush and bring it into T-Splines, our T-Splines to NURBS conversion, and a little example of a NURBS manipulation. The next step into this process is, we can bring this into SolidWorks. And we can edit and manipulate this inside of SolidWorks. So again, this is, as Matt mentioned, this is a Rosetta Stone software where we can bring that scan from the original triangles, original polygons with the messy topology in through a number of software packages where with unique and individual tool sets, and all the way into an engineering software with parametric smart data. So it truly is a Rosetta Stone process where you can bring polygons into parametrics.
And just one comment, that SolidWorks application you're showing is the TS elements for SolidWorks application, which will import either T-Spline or OBJ data. Kevin, would you be able to show maybe with that low res head just how you convert that to NURBS, just to show that conversion step?
Okay, so here we've got our, you can see this is a T-spline surface, and the conversion into NURBS is that fast at this poly count. So here's our patch layout in NURBS, and let me go out on a limb and run a Boolean process on this. Yeah, there we go.
So that's yep, it's just a push button conversion of NURBS like that.
Yes.
So really, just to sum that up, Kevin, bringing scan data through ZBrush into T-Splines, I mean, most of the work is inside ZBrush, and a lot of that is, I mean, as you showed, it's pretty straightforward just to get the right mesh level. And then once you got that right mesh level, then it's just kind of just a few push buttons to bring it into the rest of your process.
Yeah, ZBrush gave us the retopology. ZBrush took us from let's hide this. ZBrush took us from this to this and gave us a nice flowing quad mesh layout. You can do as much or as little as you want inside the ZBrush environment with the ZBrush tools, but if you want to use precise machining and do nice wall thickness and take advantage of the Rhino and T-Splines tool sets, it's just saving that ZBrush file out as an OBJ, importing the OBJ into Rhino, which is all quads, and converting this into T-Splines. And again, converting it into NURBS.
Awesome. Well, that's kind of the first part of the T-Spline ZBrush workflow that we wanted to flow, bringing in scan data. Would you be able to show something now about how you can use ZBrush to add some detail to your T-Splines model?
Let me take this. This is our T-Splines model, and I'm just going to make an obvious change so we can see that it was brought from here. We'll take this and export this file, export it as an OBJ. We'll call this okay, now you don't want to you want to make sure it's a poly mesh instead of NURBS, because ZBrush won't open it that way. You want it welded, because if you export, go ahead.
Oh, you may want to export this when the T-Splines is in box mode, Kevin, so that it.
Okay.
I'm not sure. It may just mesh it finely if it's in NURBS. I guess I'm not sure which one you prefer, but.
Well, I'll show you how this comes in
Okay,
in box
awesome.
mode. Export selected, new TS head, and again welded, poly mesh. Okay, it's written. Excuse me, my allergies. Matt, I'm still waiting for a pollen decimation tool. Okay, so I'll import the new TS head. We'll take all the tessellation. So let's rotate this around. This is our OBJ that we brought from a T-Splines object. Now this is going to be functional with all of the ZBrush tools. So you can literally go back and forth and bring this down, export this again, let's hide this. And let's import the OBJ. Okay, this doesn't have enough fidelity to show too much that sculpt snake that I did on the face, but this is it. This is the ZBrush back from T-Splines. You know, basically you can go back and forth between the two. Whenever you need a tool from ZBrush, you can go into ZBrush and get it. When you need a tool from T-Splines, bounce it through the OBJ conversion, and you're back in T-Splines. So again, I take this.
Hey Kevin, I think if you throw the throw a shiny shader on that and hide your ISO params, you'll be able to see that modification.
Okay. Let's hide the isoprams. It's shiny. Now let's smooth it. That's going to take a second. There we go. Yeah, you're right, Kyle. Now, this is going to be as tight or as loose as you dictate. So I can bring in a locket. I could in ZBrush sculpt a locket, put pores and eyelashes and whatever detail. But this is a very simple back and forth conversion. Any other questions?
Well,
And there was one question. There was one question about if you could show the button click for showing the ghosted version of the bag that you wrapped over the model before you reprojected.
Sure.
Sorry, Matt, didn't mean to interrupt you there.
oh, hey, that's all right.
Okay. Everything. This is imported in a different location. So let me do that process again. I'll hide this. Okay. So here's our original scan, and this is a this is just a viewing utility inside of ZBrush for dealing with multiple subtools on the screen at one point. So I'll remesh, and the active tool is highlighted here by this dark band below, and that's my active tool. If I'm sculpting on that. Now, if I switch to this tool and make this tool active, this is my dominant tool. Okay, so back to the question. The ghosting, there's a little bit of ghosting there, but there's another tool down here below activate opacity. The ghost transparency will ghost out the tool that is not active. So right now, the active tool is the original scan. Right now, the active tool is the bag of quads that I created. And again, that's down here, the ghost transparency. And I've got my resolution way down low, so there's a quick data transfer in this webinar. But so some of this stuff is not where it usually is on my monitor when I work, but it's down here. This is the ghost transparency tool. Anything else?
Let's see. Is that the main? I think we covered most of the main points we wanted to show. Is that right, Kevin?
Yeah.
Yeah. If you could maybe just take maybe just a minute or two just to show some of the nice tools that ZBrush has for sculpting. We just touched a little bit on that with drawing on the face, but if you could just touch a little bit more so we can just see you work. Just a few minutes in ZBrush to see a little bit more of why you would want to come into this program. And then maybe while you do that, if you could just make some comments as to, I know that we'd both wanted to share some of the work that you've done combining T-Splines and ZBrush, and unfortunately all of that is confidential at this point. But if there's anything that you can talk to as far as maybe examples or situations as to where you found this workflow most useful, like with dolls or toys, or just maybe some examples of places where this has really saved you time.
Well, the benefit of being able to use ZBrush is, let me subdivide this again so we have a nice, higher def mesh. You can't see this right now, but what I'm using is a Cintiq tablet. So I'm drawing with a Wacom pen on the screen, and it's a brush-based, pressure-sensitive utility. And I started my 3D experience using Alias Studio tools, using 3-point curves and NURBS surfaces, and I was building toy prototypes that would be rapid prototypes, CNC'd or SLA'd for presentation services purposes, but you couldn't do sculptural brush-based textures and all this nice sculptural stuff rather than digital modeling, digital 3D drafting. You couldn't do the sculptural stuff with the tools that I had available. So it limited the kind of projects that you could build for rapid prototyping. And with T-Splines being able to convert quads, it opened up my ability to use brush-based software. I mean, there's Mudbox, there's Freeform, which is voxels that can output. Well, actually, I don't think Freeform can output quads. You'd have to bring it into ZBrush or Topogun and convert it into quads. but T-Splines has allowed me to be able to create something like this from scratch, whether it be a doll or a character, and be able to bring it into Rhino or T-Splines and boolean out hinges so I can articulate an action figure, or I can give it wall thicknesses so I can send it to a factory where they can make molds and do costing and everything else. From inside of ZBrush, you can export this as an, I guess there's a utility that you can export as an STL, and you can 3D print out, you can SLA your pieces from ZBrush, but without T-Splines, you can't really, and your file doesn't really mean anything to an engineer. And I'm always interested in the technology, the digital technology of what will allow me to take a designer model and make it useful to engineers. I hear a lot of people that want to use digital workflows in manufacturing, but they have a lot of experience with vendors giving them 3D files that they can't use. So they get a nice rendering or a nice SLA, but they can't do anything down the pipeline with that data. And it's really frustrating to do, to build a 3D model and not be able to do anything with it. So being able to bring this into engineering and surface modeling software, suddenly this can be imported and manipulated by engineers. And what you don't want as a 3D artist is to build a beautiful piece for presentations only to be rebuilt in an engineering software. And anybody that's gone through that painful process has watched their babies get massacred by engineering software like SolidWorks or Pro-E. And SolidWorks can do amazing modeling. It can do organic modeling, but it's very arduous, and that's not really what it's built for. So let's use the software that's built for the task at hand and not ask too much from each of the packages. We need to understand the strengths and weaknesses and only use those strengths and weaknesses. So what T-Splines is able to do is allow me to use the strengths of the best sculptural software and be able to bring it in, like I showed, into SolidWorks or Rhino, and have the data that I started out in a brush-based software be useful all the way to tooling and costing and engineering. Does that make sense?
Awesome. Yeah,
that's an awesome demo, Kevin. I think the story here is taking these pieces, taking the best tools out of each one of these packages and stringing them together to really kind of connect two worlds that have previously been unconnectable. And the rapid prototyping or reverse engineering workflow has typically been reserved for really specialized software users and companies that can afford packages that are $30,000 and $40,000 in order to be able to do this. And correct me if I'm wrong, but I think ZBrush is what, about $600 or $700, and or no,
yeah,
$500. And T-Splines is in that same neighborhood, and so for under $1,000, you've got a workflow here where you can take a brush-based model that's polygonal, and the end of this, fast forward to the end of the story, which is SolidWorks, which is a usable imported NURBS model that the engineering department can actually build off of, instead of it just being an imported dumb solid. So that story is really powerful, and it's something that always strikes me as the fact that T-Splines was the critical piece in that story to allow that kind of round trip and all those worlds to connect, and for everybody to be able to work in the best piece of software to do the best job. So it really has removed a lot of compromise, and it's opened a lot of avenues that I think to a large extent have yet to be explored. And one of the things that we like about these webinars is we kind of take, you know, this strung together harebrained idea or workflow and throw it out to you guys, and then, you know, we'd love to hear input from you and love to hear input and see models and have thoughts and have this kind of be an ongoing dialogue as to how this can develop. And we're fortunate enough to have some folks from Pixelogic actually sitting in with us on this webinar, and I think there's an opportunity to really improve this process with some thought put into how these tools can work together better. So I think that's a really exciting opportunity, and I know it's something that you and I have been working on for a long time, and you were the one that really kind of cracked this workflow open, and it's really exciting to see, and I can't wait to see how it develops in the future here.
Okay, well, thank you very much, Kevin, for the demo of how to take in scan data and push it through ZBrush and the T-Splines and into engineering applications, and then also how to go back to ZBrush to add additional detail. As you leave the webinar today, there'll be a pop-up with just a brief questionnaire. If you could fill that out, that'll help us improve our webinars in the future. Let's see. Sounds like someone's birds got let loose. But so again, thanks again for coming. We'll just have a few more minutes for questions, and let me just see what other questions we have for Kevin. Kevin, could you show again how to export a quad from ZBrush with different mesh sizes, like the one part with sculptural details and the rest just rough?
Okay, so this has got 6 levels of detail. It goes all the way down to our original low poly bag. Now, when working inside a ZBrush, I can make some pretty drastic changes, and all these layers are connected. That change will be represented in each level of detail. And there's workflow benefits to that, there's reasons for that, but it also is a memory tax. So these can be deleted or added to. But what's great is I can take each one of these layers, each one of these levels of detail, export as an OBJ, save, come down to another level, export again,
So Kev, here's just a kind of a rephrase of that question. Mads was actually wondering if it's possible to have part of the sculpt or part of the sculpture be high detail and part of it be low detail.
part of it be high and part of it be low.
Yeah, like lots of quads in one area and then just a few quads in another area.
So you're talking about dynamic tessellation. If you want a lot of polygons in the hair and less polygons in the face, anything can be done, but that's going to require a workaround. What I would do is I would make the hair and the face separate objects.
Sure, that makes sense.
I would select all the hair. And there are, pretty sophisticated tools for making these selections. I'm just real quick.
So you just break it up into two separate parts.
Yeah, break it up into two separate parts. Export this at say level 4, and I'd export the hair as one level, and then export the face at another level. And the way that that's done, and I keep messing that up, is, okay, if I export now, let me show you in display double faces so you can see what we've got here. If I export as an OBJ now, it will only export the quads that are showing. It won't export the quads that are hidden.
That's nice.
So if I export this at level 4, and then I switch, this is a toggle, it's a shift control drag toggle, and this will show me the inverse of that selection. And if I drag this down, I don't know if it's going to let me drag, yeah, it'll let me drag while stuff's hidden. If I export this, I'll have two separate objects that I can either stitch or Boolean together in Rhino. That's a difficult thing. It's a good question, but that's a difficult process to have dynamic tessellation.
Yeah, well, that's something that maybe we could explore even ways of improving that, because one of the benefits of T-Splines specifically is that you can have areas that are high detail and low detail on the same mesh. So being able to automate that.
Inside of T-Splines, you could select a number of quads and then subdivide those, and you'll get a lot more definition in those areas.
Yeah, so this may be something we could work out. A better way of getting that in from ZBrush with some high and low detail on the same model.
You know what would be great? A quad decimator.
Sounds like that was a perfect question.
I would love that. I am pining for a quad decimator.
You knew I had to stick that in there somewhere, Matt.
Yep. All right. Let's see if we can mute that guy. Okay, just a few more questions about decimations. Ryan, I think we're just all exploring on the screen ahead of us, in front of us. So if any of you, have experiments, we'd love it if you came and posted them on the T-Splines forum or the ZBrush forum. We'd love to see kind of what you're able to do with that. Any other questions? Okay. Well, thanks again for coming. Let me just choose the presenter back to me for a sec and just flash up. Again, we'd like to say thanks to Kevin Pascoe for putting on this webinar with us today. And if you'd like to learn more about Kevin, you can visit his website, cropcircleportal.com. You can learn more about T-Splines. Come to tsplines.com. You can get a free trial of T-Splines for Rhino or TSplines for SolidWorks. And again, to learn more about ZBrush, visit pixelogic.com. So thanks again for coming, and we'll see you at another webinar.